Okay, in this tutorial we are going to look at how to predict products for a single displacement reaction type. I put a note on here in your OHM assignment whenever they're going to have you classify reaction types. A single displacement reaction is also known as an oxidation reduction reaction. So anytime you would check a box for single displacement, if they also give you this option, make sure that you check both of those for it to be completely correct. So that's what note I just wanted to make sure you guys were aware of. Whenever you're predicting products for single displacement reactions, you can identify single displacement because you have an element plus a compound. And that's what we will identify as single displacement. In order to predict products for single displacement reactions, you need to refer to what we call an activity series chart. This I had uploaded in D2L, a copy of it. So I just made this note on here, which you can add this note to yours as well, just kind of offering additional explanation as to how this works. Basically, it's a list of your elements, your metals on the left, your nonmetals on the right, and it tells you basically order of reactivity, how reactive the elements are. So in this case, hopefully you have already watched the classification of reactions tutorial and read through that chapter, because this is going to go a lot more smoothly if you have the general understanding of how these work. So in a single displacement, we know that the element by itself is looking to replace an element in a compound. If the element by itself is a metal, it can only look to replace the metal in the compound. So in this case, zinc is looking to replace or to kick out silver. In order to know if zinc is strong enough or able to do that, we have to refer to the activity series chart. I would look up zinc and I would look up silver. Since zinc is above silver, it is able to kick it out. So I put a note on here: an element can replace any other element that's below itself. So since silver is below zinc, that can happen. So when I'm predicting my products, silver gets the boot, and now zinc has stolen the partner of the nitrate, and those two are now going to come together. Now, that's always my first step in predicting products, is putting kind of like the general elements where they go, and then I have to next determine what subscripts, if any, are needed when these new elements are now reformed in different compounds. So we talked about elements by themselves will never have a subscript unless it's one of those 7 diatomics that you wrote on your note card in the Unit 2 lab, which silver is not. Then we have zinc and nitrate together. Zinc, from, again, last unit notes, I told you, even though it's a transition metal, zinc is one of the few that has a set charge of +2, so make sure that you have made note of that somewhere. Nitrate, if you look at your polyatomic ion chart, has a charge of -1. So when these two groups come together, they are not balanced, so I need a subscript of 2. In order to balance out those 2 new ions that have come together. My last step whenever I'm predicting products is just to balance. So I have 2 nitrates over here. I need a coefficient of 2 to balance out the nitrates, and then I have 2 silvers, so a coefficient of 2 to balance out the silvers. All right, let's look at the next one. I have copper reacting with iron sulfate. This is iron 2, based on if you were to solve it like we learned back in Unit 2. I want to know, again, copper is a metal, so it can only replace the metal in the compound. So I'm looking to see if copper is strong enough to replace or to kick out the iron and for this reaction to occur. So I'm going to go ahead and look up copper and iron. So copper is not strong enough to kick out iron because iron is above copper on the activity series chart. So since it is lower than iron, it is not strong enough to kick it out. So we would just write that there is no reaction. If you put copper in an iron sulfate solution, it would just sit there. Nothing would happen. All right, then we move on to our next one again. Single element plus a compound is a single displacement. Aluminum is a metal, so it's looking to replace the metal in the compound. Metals are always listed first in the compound. So aluminum is looking to replace lead. If I look at aluminum, look at lead. Lead is below aluminum, so that means aluminum is stronger than lead and able to kick it out. So lead gets the boot. And then what's left is the aluminum compound. So now aluminum has stolen the partner of the nitrate. So I'm going to just put the NO3 right now, stick it in parentheses. And that's what I have. Remember, you only carry subscripts if they're part of the polyatomic ion, because that unit is called NO3. You're not going to carry any subscripts that are there, that were there in order to balance out an original compound. Again, that was all back in unit 2. So when we now look at our product side, lead is an element. Elements are always left alone unless they're one of the 7 diatomics, which lead is not. In the compound, aluminum has a +3 charge, nitrate has a -1 charge. So in order to balance out these two, when they come together, I'm going to need that subscript of A3. So my last step is just to then balance the equation. So if I look through this, my nitrates, I have 2 and I have 3 over here. So I'll need a 2 here, a 3 here. Then I have 2 aluminums, and then my leads, I need a 3. And there's my coefficient, so that's done. All right, in my next example, I have chlorine, and it is reacting with the element chlorine, reacting with sodium iodide. That element chlorine has the 2 with it because by itself, chlorine is one of those 7 diatomics, so it needs the 2 when it is alone. Chlorine is a nonmetal, so in this case, since it's a nonmetal, it is looking to kick out the nonmetal in the compound, which is the iodine. So I want to know if chlorine is stronger than iodine, so I'm looking on my right side now. Chlorine is above iodine, so it is stronger and it is able to kick it out. So iodine gets the boot. And then the sodium is now going to be combined with that chlorine. Okay, the subscript drops because it's in a new compound. All right, so on my right side, I just have to refigure out what my subscripts are. Iodine by itself, it's a diatomic. So by itself, when it's out of a compound, it is one of the 7 elements that needs a 2. When sodium and chlorine come together, it's a +1, -1. Using your charges, those balance, so I will not need any subscripts. So the last thing that I have to do is just balance it. I have 2 iodines. I need a coefficient of 2 there in order to balance out my iodines. The 2 here will balance my sodiums and my chlorines. All right, for my last example, I have nickel reacting with hydrochloric acid. I threw this one in because nickel's a metal, but if you'll look, there's no metal. Hydrogen and chlorine are both nonmetals. However, so when that happens, when you have a metal, but then there's no actual metal in the compound for it to replace, then you just look at something that is a like charge. So nickel is a positive charge. Again, this is based off of the periodic table back from Unit 2. Please go back and review that if you've not done so. It's heavily used in Unit 3. But nickel's positive charge and hydrogen is also a positive charge. So even though it doesn't qualify as a metal, they do have the same sign as far as being positive, so that's what would be looking to replace each other. So nickel versus hydrogen, if I take a look at my activity series chart, I see nickel here. Hydrogen is down here, so since nickel is above hydrogen, it is strong enough to kick it out. So hydrogen gets the boot, and then nickel and chlorine come together to form a new compound. Okay, so now I have to check my elements and compounds and see if there's any subscripts. Hydrogen is one of the 7 diatomics, so by itself it needs a 2. Nickel, I tell you at the bottom to assume that this is nickel 2, so nickel's charge is a +2. Chlorine's is a -1, so I need this to be a subscript of 2 in order for that compound to balance out. As a big picture, I have 2 chlorines, so I need a coefficient of a 2, 2 hydrogens, and now all of my atoms are balanced. So that's how you predict products for single displacement reactions, also known as oxidation reduction reactions. You must have the activity series in order to know if that element is strong enough to kick out the other element. If it is not, you write no reaction. If it is, then you continue predicting what your new element compound combination is. Again, taking that extra time to put in your new subscripts.